Hello everyone. Now we're going to do notes on reflections. This is page N4 in your transformations packet. So let's start by filling in some of our notes. So a reflection is a transformation which flips the figure over a line, or we could say axis as well. This line is called the mirror line or line of reflection. This line of reflection is probably used more commonly. However, you'll see mirror line in at least some of your notes this unit. So you should be familiar with both. So let's start with example 1. Triangle ABC is being reflected over the x-axis. So the first thing I like to do is draw in your line of reflection, and I went ahead and just darkened the x-axis in because it matches what we're asked to do here. You use this notation to write that triangle A reflects to triangle A prime, B prime, C prime. So then they've asked us to draw and label the image of triangle A prime, B prime, C prime. Let's start with A. Now I already have it filled in, but this is how I did it. I started with the original point and I counted how many steps I was away from the line of reflection. And that's 1, 2, 3. And then I continued that same amount past the line of reflection. 1, 2, 3, and I got A prime. So B is tricky. Since it's on the line of reflection, it doesn't move. So I went ahead and marked that also B prime. And then point C is, let's see, 1, 2 away. So I'm going to count 1, 2 past and label it C prime. I'll let you guys catch up a little. Then I'm asked to write the new coordinates, the coordinates of the prime numbers. So I've already filled in the original points, and the prime numbers are going to be, let's count. So A prime is X is 1 and Y is 3. For B prime, well, it's the same point. So I'll just fill in that same coordinate. For C prime, I go out 4, so X is 4, and then Y is 2. Okay. Then I'm asked, write a general rule for an x-axis reflection. Well, let's talk about this. So all my x values, what's going on with those? Well, those are the same, right? 1 is 1 and 3 is 3 and 4 is 4, isn't it? So for every x, I'm going to have x. But then my y values do something different. Every time I have my y value, it's basically the same number, but the opposite. So I'm going to write the opposite of y. In this case, they move positive, because we can remember if we take the opposite of -3, we get a positive 3. Well, the opposite of 0 is still 0, and the opposite of -2 is a positive 2. Okay, let's take a look at example 2. I have some of it already filled out. So triangle ABC is reflected over the y-axis this time. So I've already drawn in my line of reflection, as you can see, and I labeled it the y-axis. So we have to go, if this is our mirror line, we're going over this, right? So when I go to find A prime, I am just counting how many spaces I am away from the line of reflection, then again, repeating that count till I get to my new prime spot. So A prime is 1 space away from Y, so it's 1 space to the other side. And I label it A prime. B is 1, 2, 3 spaces away, and then I go 1, 2, 3 beyond, and C is the same, 1, 2, 3, 4, and 1, 2, 3, 4 past that line of reflection. Label your points primes, and then I connected to make my same shape. And I can see that I'm probably correct because it just looks right. It looks like this is a reflection line, and this shape is the same. It's just flipped over. Then I'm asked to fill in my new coordinates. Well, my x value is going to be, well, these are opposites, so it's going to probably be the other. It's going to be a slightly different rule in the end. Okay, so A prime is -1, -1, 2, 3. B prime is -1, 2, 3, and 0. C prime is -4, -2. Okay, and then write the general rule. Well, my x value, again, is the one that takes the opposite, isn't it? Because as you can see, I have all positives here, 1, 3, 4, and then the opposites of these, -1, -3, and -4. So opposite of x, and then my y value stays the same. And there's my rule.